কেউ ইউনিভার্সিটি এখন ছাড়া জয়েন করছো? Okay, so good morning everyone. Welcome to the class of CE331 Environmental Engineering 1. So today we will discuss about coagulation theory. So far we have discussed sedimentation theory and we solved some problems on sedimentation theory, right? So today we will start with the coagulation theory. First of all, a large portion of suspended particles in water are sufficiently small, which is less than 50 micrometer. You know what is micrometer? Hmm? Micro means 10 to the power minus 6 meter. Micrometer means 10 to the minus 6 meter. So a large portion of the suspended particle in water are sufficiently small, less than 50 micrometer, that their removal in sedimentation tank is impossible at reasonable surface overflow rate and detention time. So if you have a detention tank here, sedimentation tank or detention tank, okay, water comes here and goes exits from here. Now, if the particle is very small, then it is very difficult to settle them down. Are you following me?
Yes, sir.
Yes, sir.
Because their weight,
Yes,
self weight,
sir.
is very small, and due to the reason, due to this reason, it's very difficult to drop them or sediment them. Yes, you can sediment them theoretically by increasing the length a lot, but this is not theoretic. I mean, this is not practically possible because you need a lot of space and money to do this. Okay, so what do we do in that case? Larger particles, yes, they will easily settle down, but smaller particles, they will not easily settle down. Now, how to remove them? Usually, we use coagulation process to remove them. Coagulation process. This is called coagulation. What happens in coagulation process? Here, as you can see, um, these smaller particles, right? The smaller part. If you zoom them out, if you zoom them out here, zoom, okay, zoom in, you'll see that these particles are maybe a bit larger. This, these particles, I'm talking about these particles, smaller particles. I've zoomed in, okay? These particles are surrounded by negative charge. These particles are surrounded by negative charge. Similarly, another particle here, this is also surrounded by negative charge. Now, since they are surrounded by, since both of them are surrounded by negative charge, same charge, so same charge does what? Attraction or repulsion? Hmm?
Depulsion. repulse.
So they will repulse each other, repulse each other. Therefore, they cannot come close to each other. They cannot come close to each other. That means they remain isolated. And they remain isolated means they are still smaller particles, and the smaller particle means they are very hard to settle down. If you somehow you could bring them together, for example, 1,000 particles together here, 1,000 smaller particles together, what would happen? It would have been a larger mass, right? It would have been a larger mass, right? Don't you think this is
Yes,
logical
sir.
in this
Yes,
one?
sir. Yes, sir.
Now, if it were a larger mass, you bring all of them together to bring a larger mass, then it would have been easily suspended. But as you can see, due to this negative charge, they cannot agglomerate. They cannot come close to each other. Therefore, they do not settle down. That means they are stable. This is stable form. And this is unstable form because this is larger mass, it will settle down. This is unstable form. For water treatment, what do you want? Stable or unstable?
Unstable.
Unstable. Because you want to remove them, right? Right?
Yes, sir.
So one thing we observed that usually these smaller particles are stable, and the reason is that they are surrounded by negative charge ion, which is kind of a layer of ion surrounded surrounding the particle, and this negative charge repulse each other, and due to this repulsion they cannot come close to each other, and therefore that's why they are stable. So that's what they're telling, the stability of colloids. What is colloid? These smaller particles are called colloids. Okay, colloids. The stability of colloids. So the colloidal particles in natural water are stable because of their surface charge, usually negative, as I told you. The stationary charge layer on the surface is surrounded by a bond layer of water in which ions of opposite charge drawn from the bulk solution, with greater concentration in the vicinity. This arrangement produces a net charge that is strongest at the boundary layer and decreases. So what they are trying to say here is, due to this negative charge, they draw other positive charge species here. They draw other positive charge species, and similarly here. Okay, and this same charge repulse each other. this same charge repulse each other, and therefore they cannot come close to each other, and therefore they are stable. Okay, clear?
Yes, sir.
Okay. This arrangement produces a net charge that is the strongest at the boundary layer and decreases exponentially with distance from the colloid. When two colloids come in close proximity, there are two forces acting on them. Now, there are two things. One is electrostatic repulsion, another one is van der Waals force of attraction. What is electrostatic repulsion? This is electrostatic repulsion. This is electricity, right? And these are positive charge. This is positive charge. So same charge, repulsion. So this is electrostatic repulsion. An electrostatic potential is created by the counter ions surrounded each colloid. As two similarly charged particles approach each other, similarly charged particle 1, 2, similarly charged particles approach each other, their diffuse counter ion atmospheres begin to interfere and cause particles to be repulsed. So when they try to come close to each other, these similar charged layer, it's a layer, right? Double layer, negative, positive. So one layer, two layer, one layer, two layer. Okay. So double layer. So these two double layers, and here this double layer, similarly charged, they repulse each other. When does this happen? It happens when the particles try to come close to each other. Is it clear, guys?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, what is van der Waals force of attraction? Now, somehow, anyhow, if you can manage to bring them close to each other, anyhow, okay, we will discuss how later. But anyhow, if you can manage to bring them close to each other, like this and this, very close to each other, here, then interestingly, an attraction, an attraction gets activated. That is called van der Waals force of attraction. Can you remember the name?
Yes, sir.
Yes, sir.
Van der Waals force of attraction. It is activated only when you bring the colloids very close to each other, defying this ionic layer. If you can do this, then they attract each other. They attract each other and get connected and get connected. Okay, so that's how. So one thing we understood that when the particles are apart, then repulsion dominates. Repulsion dominates. Far away or apart. When the particles are close, then Who dominates? Van der Waals force of attraction dominates. Clear?
Yes, sir.
Now, your objective is to do this. Therefore, your objective is to bring them, somehow you bring them close to each other. If you can bring them close to each other, then this van der Waals force will automatically be activated and they will agglomerate together. They will uh, agglomerate together to make a big mass, and that big mass can be settled down easily. So van der Waals forces of attraction. The second force, an attractive force called the van der Waals force. I did a mistake here. Spelling mistake. WA. Van der Waals force of attraction. Support contact. This force is inversely proportional to the sixth power of the distance. Did you see? Sixth power of the distance. That means closer, smaller the distance, higher is the van der Waals force. Smaller is the distance, higher is the van der Waals force. এখানে ডিস্টেন্সটা কি হাই, রাইট? Higher is the distance, smaller is the van der Waals force. Clear? Clear.
Yes,
Yes,
sir.
sir.
We may also
Yes,
call
sir.
it attraction. A. Attraction is higher. But higher is the distance, stronger is the repulsion. Smaller is the distance, smaller is the repulsion. Clear?
Yes,
Yes,
sir.
sir.
So as you can see, this is distance and attraction. They have an inverse relation. Inverse. In decrease, increase, increase, decrease. Okay. So that's why the sixth power of the distance inversely proportional the sixth power of the distance between the particles. That means they try to mean is that A is proportional to inversely proportional to x, sixth power of the distance, and also decays exponentially with distance. It decreases more rapidly than electrostatic potential, but is a stronger force at close distance. It becomes stronger when they are closer. The sum of the two forces, as they relate to one colloid, each close proximity to another is repulsive as greater distance. So what does this mean? So let's look at this figure. A. Let's look at this figure. What we are drawing here is this. When the particles are apart from each other, you plot this. This is xy, x-axis and y-axis. This is positive, this is negative. This is positive, that means this is negative. So let's repulsion here. Let's call it repulsion. This is zero line, right? This is repulsion. So this will be attraction. Negative will be attraction, right? Am I right?
Yes, sir.
And if this is the particle, this is their distance, right? The distance is here, d. Here you have the repulsive force, and here you have the attractive force. Now, low electrolyte concentration. লো ইলেকট্রোলাইট কনসেন্ট্রেশন মানে কি? ইলেকট্রোলাইট মানে হচ্ছে আয়ন। ইলেকট্রোলাইট মানে হচ্ছে আয়ন, রাইট? পজিটিভ নেগেটিভ চার্জ এগুলো। নাও in a room, if you have 10 people, 1, 2, 3, 4, or 5 people, 5, and in the same room, same size room, if you have 1,000 people, in which room the particle will be closer, A or B?
B.
B, because you have high electrolyte concentration. And you have here, what is this? Low electrolyte concentration, right? Low electrolyte concentration.
जी सर.
So when you have low electrolyte concentration, that means your distance is higher. Low electron means distance is higher. That means the particles are away from each other. So that means low electrolyte concentration, when they say this, that means you have to assume that the particles are at a larger distance. What happens in that case? In that case, as you can see, if you draw the repulsive force, as you draw the repulsive force, repulsion, double layer repulsion. I already told you what is double layer. This is double layer repulsion. It works like this. Repulsion. Double layer repulsion. What happens about the attraction? This is the attraction. This works like this. Okay. That means that if they have a distance of, for example, 100 micrometer, 100 micrometer. Let's say this is 100. Then it will be, the repulsive force will be what? The repulsive force will be maybe 50. We don't know the unit, I'm just writing it 50 unit. When the distance is 150 micrometer, then it is around 40. Repulsive force is 40. Okay. Similarly, at this 100 micrometer distance, what is the attraction, guys? What is the attraction? What is the attraction? This is the graph.
0.
0. It goes like this. It's 0. Here also 0. So who will dominate at this distance? Tell me. Who will dominate at this distance?
Sir, repulsion.
Sir, repulsion.
Because there is no attraction. There is no attraction. Okay? There is no attraction. Okay. Now, the total attraction. Total attraction is what at this point? At this point, the total force. Total force is 50 minus 0. This is 50 at this point. At this point, what is what? 40 minus 0. Why 0? Because attraction is 0. Equals to 40, right? Right?
Yes, sir. Yes.
At this point, let's see about this point. This may be around 50, I don't know. 50. At this 50 micrometer distance, D, what is your repulsion? Maybe, I don't know, 70? 20 maybe? Okay. What is your attraction at this point?
10.
10 or 20? Right? Now, what is the total force here? Tell me. What will be the total force here? Hmm?
20.
70 minus, this is positive and this is negative, right?
Yes,
70
sir.
minus
50.
20.
Okay, sir.
So 50. So resultant will be where? At 50. Maybe here. At this point, resultant is here. At this point 100. Resultant is here. Here. Now, tell me one thing. At this point, this may be 10. What is the repulsion? Maybe 90. At this point, what is the attraction? Look, shiny. So it's a lot, a whole lot. It's maybe around 100. Did you see? At this point,
Yes, sir.
it will be 100 minus, sorry, 90 minus 100. And you can see this is negative 10. Negative means what? Attraction. So here, it will be at this point, it's negative 10. That means here. Am I right? Am I right?
Yes,
Yes,
sir.
sir.
Now, if you plot the resultant, if you connect these points, you will get the resultant force. Because here two forces are acting together. The result, you have to take the resultant, positive and negative, in opposite direction. One is repulsion, one is attraction. So you have to take the resultant. So if you connect this, you'll get this. You'll get a curve like this. Am I right? Get a curve like this. All right,
Yes, sir.
and you'll see curve like this. This is the resultant. Clear?
Yes, sir.
The initially it was repulsion, then it starts decreasing. Then after very close, that means D is very small. At a very close distance, who dominates? At a very close distance, who dominates? Van der Waals force of attraction. At a larger distance, who dominates?
Repulsion.
Repulsion.
Repulsion. This is the resultant. This is the resultant. Okay. At larger distance here, who dominates? What is the resultant? Positive. Positive means repulsion. But at a smaller distance, in closer distance, who dominates? What is the resultant at this point? Attraction dominates. Clear?
Yes, sir.
Now,
Yes, sir.
if you increase the electrolyte concentration like this, then the distance will be, the particle will come close to each other. Then how would this graph look like? The graph will look like this. You see that now this repulsive layer has been compressed like this. Did you see?
Yes, sir.
It has been compressed. And you see the contribution of the repulsion has been decreased. Previously, the contribution of repulsion was is larger. Now this is smaller. Do you see? Smaller. Okay. So this is intermediate electrolyte concentration, which is higher than the low electrolyte concentration. Now, if you even further increase the electrolyte concentration, high electrolyte concentration, then the particle will be even closer to each other. Yeah. So, guys, are you following me?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Yes, sir.
So, if you um increase the electrolyte concentration, that will be high electrolyte concentration, then this double layer will further be compressed. Here, you can see further be compressed. And you will see that majority of the cases this resultant is at the negative part. That means always the attraction dominates. Clear?
Yes, sir.
There is no component like this here in the repulsion part. All are negative. So that's what happens. So your that means here the particles have come close to each other, and therefore they are agglomerating together, and they will make a bigger mass, and then it will be easier to settle them down. So you want this. So what you need to do is you have to bring the particles close to each other. Okay, like this is the repulsion, and here this is attraction. And if attraction works, then aggregation of colloid particles happens. Okay, so these are the negative charge, and negative charge are surrounded by positive charge. Okay, now we have learned how the colloids become stable in water. We learned that when two colloids come close to each other, then two things happen. One is electrostatic repulsion, and the another one is van der Waals forces of attraction. And while looking at these mechanisms, we understood that if we can bring the particles close to each other, then this will dominate, and our water treatment or removal of particles will be efficient. So what we need to do is to destabilize the colloid. Destabilize, unstable, make them unstable. That is destabilization of colloids. How you can do this? There are two methods. So far, we have identified two methods. One is ionic layer compression. As I just told you that if you can increase the concentration of electrolytes, then the particle will be congested and come close to each other. Am I right?
Yes, sir.
Yes, sir.
So this is ionic layer compression. Why ionic layer compression? Because there are a lot of people here, a lot of people here. So they are the charged will now be what compressed. Another particle, for example, here is gonna push it here. He's gonna push it here. So this layer is gonna compressed. This layer is gonna be compressed, even though there is a repulsion. Remember, even though there is a repulsion, but they will be compressed by other particles because they are very small space. All are trying to occupy the space. So therefore they will push each other, and from all sides there is pushing, pushing, pushing. So they will be compressed. And if you can compress them, that means you are bringing them closer, right? So that's the way how you can destabilize the colloids. So one is ionic layer compression. The quantity of ions in the water surrounding a colloid has an effect on the decay function of the electrolytic potential. A high ionic concentration compresses the layers composed predominantly of counter ions toward the surface of the colloids. If this layer is sufficiently compressed, the van der Waals force will be predominant across the entire area of the influence, so that the net force will be attractive and no energy barriers will exist. What is energy barrier, by the way? The thing is that this charge, this double layer charge, is hindering the process of coming close to each other. Therefore, this is called energy barrier. This is the barrier of energy. This is a barrier of energy. This is a barrier of energy. Okay? This is a barrier, energy barrier. So what is happening that if you have higher ionic concentration, then as I told you, other particles will be pushing them from all sides. Therefore, this layer will be compressed. This layer will be compressed. Okay? And they will come close to each other. Are you following me, guys?
Yes, sir.
जी सर.
Sir.
Yes, sir.
So that is one process. Another process is adsorption. Look, adsorption, not absorption. Adsorption of charge and neutralization. Two things. There is one is adsorption and one is absorption. adsorption, another one is absorption. Adsorption and absorption. Absorption means, for example, a tissue paper, it absorbs the water. শুষে নেয় ভেতরের দিকে. It sucks the water inside of it. And adsorption is, uh, for example, there is a particle which gets attached with this fabric or anything. It gets attached. গায়ে লেগে যাওয়া. Okay? Gets attached at the surface. Basically, surface attachment. উপরে লেগে থাকে surface attachment. এটা লেগে আছে গায়ে উপরের দিকে. But absorption, unlike to the adsorption, in case of absorption, এটা ভেতরে ঢুকে যায়. Is it clear?
Yes, sir.
এখানে যেটা হয় adsorption of and charge neutralization. কি হলো? In water, as I told you, we have colloids, right? We have colloids like this. We have negative charge, as I told you, and then we have positive charge, right? Like this. If you can add some species in water, like aluminium, these cations, aluminium sulfate, if you add aluminium sulfate in water, what would you get? You will get aluminium ion plus 3 and sulfate ion. Like this. Basically, aluminium are found with attached in water, 18 molecule of water. Aluminium sulfate. Aluminium sulfate. এটা কি বলো তো? এটা হচ্ছে অ্যালাম. Can you remember this? এটা কি ফিটকিরি? আমরা বলি ফিটকিরি, right? Clear?
Yes, sir.
Add this in water, it produces aluminium ion and sulfate ion. And this aluminium ion, with reacting with water, produces some positive ion species. For example, this. See, this is there is an ion with them. There is an ion with them, right? Attached like this. Now, these ions, what does they do? What do they do? Tell me. The sulfate ions these aluminium ion cations react immediately with water to form a variety of aqua metallic ions. What is aqua metallic ion? This is aqua metallic ion. This is an aqua metallic ion. This is one aqua metallic ions. And hydrogen. The aqua metallic ions become part of the ionic cloud surrounding the colloid, and because they have greater affinity for surfaces, are adsorbed onto the surface of the colloids where they neutralize the surface charge. And what happens? These aqua metallic ions, for example, as I told you, for example, AlOH2 plus, right? This. Talking about this, they have a greater affinity attraction with these negative ions. Therefore, they replace these positive ions and they get adsorbed here. This is aluminum hydroxide. They get adsorbed here. in the surface. গায়ে লেগে যায়, absorption. And since they are positive charged, এই পজিটিভ এবং নেগেটিভটাকে কি করে ফেলে? নিউট্রালাইজ করে ফেলে। নিউট্রালাইজ। Is it clear? Guys, are you following me?
Yes, sir.
Yes, sir.
Now, এই নেগেটিভটা এখন নিউট্রালাইজ হয়ে গেছে কাকে দিয়ে? এই পজিটিভটাকে দিয়ে। এই পজিটিভটার it has a greater affinity to get absorbed into the surface. So it gets absorbed into the surface. First of all, it gets absorbed into the surface. And now, since this is positive and this is negative, so they neutralize this one, neutralize this negative charge. এখন আমাকে বলো, যদি নিউট্রালাইজ করে ফেলে, দেন এখানে আর কোনো চার্জ আছে?
না স্যার।
নাই।
No, sir.
না থাকলে there is no repulsive force to hinder the process of coming closer to each other. Therefore, they will come close to each other. They will, because there is no negative charge, no energy barrier. So if you can just stir the water a bit, they will come close to each other, and you'll see that very small particles have agglomerated to make a bigger mass like this, and they will easily be settled down. That's why in a bucket of polluted water, if you add fitkiri, aluminum sulfate, then you'll see, and you stir the water a bit, and you'll see that after some time larger particles are settling down, right? Which was previously impossible, but now they are agglomerating and settling down at the bottom, and you can bring the clear water from the top, supernatant. Clear? Are you
Yes, sir.
following? So that is basically charge neutralization. One process was ionic layer compression by increasing the quantity of ions, that means increasing the concentration of ions, and the another one is charge neutralization by addition of some species like fitkiri, and this is called coagulant. What is the function of coagulant? By the way, what is coagulation then? Coagulation is basically, we started with coagulation, right? We
Yes, sir.
started with coagulation. What is coagulation? Coagulation is this, that charge neutralization. This process is called the coagulation. That means defying the energy barrier, that is called the coagulation. And coagulants, what is coagulant? Coagulant is the one which helps in coagulation. For example, here fitkiri is helping in coagulation. So fitkiri is a coagulant. Okay. Read this. Okay. Read the whole thing. Any questions, guys? No question. Okay. Flocculation. Flocculation is flocculation is um, flocculation. When we neutralize the charge, then particles come close to each other, right?
Yes, sir.
This is flocculation. Coagulation was um, this I should say charge neutralization, or define the energy barrier. Particularization or define the energy barrier, and flocculation is um, aggregation of particles. Together. So once there is coagulation, then the flocculation happens. So flocculation follows the coagulation. First of all, you need to perform the coagulation to neutralize the charge, and once you neutralize the charge, then you need to bring them closer. How can I bring them closer? You can just steer it, right? You rotate this, you steer them, and if you steer them, then the particle will collide with each other, and when they collide, then there will be van der Waals force of attraction, and there will be aggregation, right? Right?
Yes, sir.
And this larger particle, after aggregation, these larger particles are called flock. Clear? So flocculation, in other way, is a way of making flock. That is flocculation. তো এটাকে স্থির করার জন্য পাওয়ার দরকার, ভলিউম অফ দ্য পাওয়ার, viscosity কত, এগুলা ফ্যাক্টর। তো ফ্যাক্টরস ইনফ্লুয়েন্সিং কোয়াগুলেশন এন্ড ফ্লকুলেশন, এটা পড়বা যে কোয়াগুলেন্ট 8 কি পরিমাণ তুমি কোয়াগুলেন্ট 8 দিচ্ছ, পিএইচ ভ্যালু এত থেকে এত রেঞ্জের মধ্যে থাকতে হবে, অপটিমাম ডোজটা ইম্পর্টেন্ট, ঠিক আছে? তো এখান থেকে জাস্ট কোয়াগুলেন্ট 8 অপটিমাম ডোজ আর মিক্সিং গুলা করলেই হবে। Any questions, guys? Coagulation and flocculation. So today we learned, this is very important in water treatment process, coagulation and flocculation. Coagulation and flocculation, very important. Any questions on these two, guys? Any questions?
No, sir.
Okay. We already discussed pH value, alkalinity, hardness, iron, sulfate, manganese, these things. Okay, now the next method of treatment. Remember, we are discussing water treatment theories. Water treatment theories. And in that we understood, we discussed in detail and also solved the problems on sedimentation. And we discussed that if the particle is very small, then sedimentation is not effective. Then we need to apply coagulation and flocculation. Now there is another treatment method, that is filtration. We will discuss about filtration now. Okay. So in next class we will start with filtration. If you have any questions, you can ask me. Any questions?
No questions, sir.
No, sir.
Okay, let's we have some time. Let's discuss. Let's start it. Filtration. Filtration is nothing but just filtering the water. Just filtering the water. That's a filtration. That means the water will, for example, you have a filter here. You have, for example, you have gravel particles. And you have water here, by the way. You have water, and in water there are pollutants. There are pollutants. Okay. Now, when the water will try to pass this, these pollutants cannot be will not be able to pass because they will be stuck, because the pore size here is smaller than their size, than the size of the particles. So they will be stuck. So as the water percolates through the pores, the pollutants will be captured by this filter, and then you will get the clean water here. That's the idea. Is it clear? These are the gravel particles, right? Are you following me, guys?
Yes, sir.
That's the basic idea. Now, in reality, this is not as simple. There are a multitude of processes that is happening here. Not only one process. There are a multitude of processes happening there. We'll see them one by one. By the way, this is called filter media. These particles are called filter media. This can be gravel particle or sand particles. Okay? So this has been captured here. This, this has been captured. Okay? Now, filtration. Sedimentation with or without coagulation will not ordinarily give clear, sparkling, and bacteriologically safe water, which requires the use of a filter. If you want to have a clear, sparkling water, then you have to use a filter. That means you have to apply the process of filtration. This is called the filter, by the way. This is the filter. Okay. Now, filtration is a process of water purification in which water from a sedimentation tank is allowed to pass through a bed of filtering media, which usually sand and gravel. As I told you, these filtering media are usually sand and gravel. And the filtrate is collected at the, what is filtrate? Filtrate is the liquid which is collected after filtration. This is called filtrate. Filtrate. Filtrate is collected at the bottom through an under drainage system. The filter media are very efficient in retaining finer and colloidal particles of clay and silt. They are referring to this. Okay. It also aids in removing color, odor, iron, and manganese. So you can also remove iron and manganese using this filter media.
Sir,
Type of
order কি জিনিস sir?
okay. First of all, you need to see that how this odor is caused in water. The odor is caused by a multitude of sources. For example, organic matter. Organic matter. Now, this is the solid organic matter. Now, this solid organic matter get decomposed, when get decomposed by the bacteria, that produces odor and others. So this solid organic matter, this can be captured. That's how we can remove the odor. Okay,
Yes, sir.
I've just gave you one example. There are numerous other examples. Okay, type of filter: slow sand filter, rapid sand filter, coarse media roughing filter. It is slow, it is rapid. So from the name, it's easy to understand that in slow sand filter, the water will move slowly. The water will move slowly like this. In rapid sand filter, the water will move fast. Clear? And in the coarse media, this is kind of intermediate. So first of all, we will see them. First of all, let's see the theory of filtration. This is important. What is happening in this filter media? One is mechanical straining. What is mechanical straining? As I told you, that these particles, when the water moves through this pore size, these particles are captured here. This is called mechanical straining. Called mechanical straining. Now, flocculation, sedimentation, adsorption. This also happens here. Flocculation. How flocculation happens? Look at this example. Here is the water coming. Here is the water coming. You have a particle here. Do you see in the water you have a pollutant? In the water you have a pollutant here. Did you see this black one?
Yes, sir.
Yes, sir.
We have a pollutant here. You have a pollutant here. Now, as the water tries to move through this pore, this water tries to move through this pore, this pore, so they are actually converging. So what would happen? That they were far apart. Now they are now they are coming closer to each other here. Am I right?
Yes, sir.
Now this process is called what? Flocculation. So flocculation is happening. Far apart, it has become closer. So flocculation is happening here. Flocculation. Sedimentation. What happens? Sedimentation. If you look at the um, chamber, this chamber acts as a sedimentation basin. This chamber acts as a sedimentation basin. When the particle tries to move from there to there, the water is trying to move from there to there, right? The water is trying to move from there to there. What happens that these particles, by the process of sedimentation, will settle down here. You see some black particles here? They have sedimented. This acts as a sedimentation basin. Is it clear?
Yes,
Yes,
sir.
sir.
So sedimentation is also happening here. Flocculation is happening here. And adsorption is also happening here. How? Here you have bacteria in this water. This is wastewater, right? Right? This is Wastewater.
Yes, sir.
Yes, sir.
Yes, sir.
Wastewater has organic matter, and this is organic matter. Red one is the organic matter, the pollutants, and bacteria feed on them. Bacteria eat them, and they grow. So therefore, you get a layer of bacteria. You get a layer of bacteria, and this layer of bacteria is gelatinous. You know what is gelatinous? Sticky, athalo, sticky or athalo. We call it biological. Did you see a layer here? Smaller layer, a smaller layer here.
Yes, sir.
Here. This layer is a biological slime. This is called biological. Why biological? Because these are bacteria and other biological slime called. You don't need to know this name. Just interception. So what happens? Since this is since this is gelatinous, আঠালো, ছোট ছোট পার্টিকেল এখানে কি হয়ে যায়? অ্যাটাচড হয়ে যায়, অ্যাবজর্পশন হয়ে যায়। অ্যাটাচমেন্টটা কি বলে? গায়ে লেগে যায়, এটা কি অ্যাবজর্পশন, রাইট? Am I right? And what
Yes,
Yes,
sir.
becomes
sir.
attached to the surface, that's called absorption. So since this layer is gelatinous, when smaller, very smaller particle tries to move with this water, they get attached. They get attached. And sometimes even bacteria, other bacteria can also be attached here because this is gelatinous. Clear? So what is happening here? Flocculation, sedimentation, and adsorption. Clear? Clear.
Yes, sir.
Okay, we don't have much time today, so we'll discuss it later in the next class, inshallah. Okay, so we have discussed process number one, process two, and process two. We have three separate processes. Number three and number four. We'll discuss it in the next class, inshallah. Any questions, guys?
No, sir.
No, sir.
No, sir.
স্যার মেকানিক্যাল স্ট্রেনিংটা একটু আরেকবার একটু repeat
Mechanical
করুন।
training is the simplest one. You have the particle here. The water tries to move. You have a space, very small space. Water particle can pass, but this is since this is larger particle, they cannot pass. They get stuck. That's it. That is mechanical straining. Straining, like if like you strain the tea leaves, right? চাপাতা ইয়ে করো না, তুমি ফিল্টার করো না,
জি স্যার।
ওইটাই মেকানিক্যাল স্ট্রেনিং। Okay,
থ্যাংক ইউ স্যার।
no problem. Okay then, thank you
Sir,
very much. Yes,
sir, sir, my attendance is given, please. Last
later,
later.
later, later. Okay, thank you.